IBM has unveiled the world's first sub-1 nanometer chip technology, a major breakthrough in semiconductor research, with its experimental 0.7 nanometer prototype pushing the boundaries beyond today's 2 nanometer and 3 nanometer chips, setting the stage for enhanced efficiency in artificial intelligence and next-generation high-performance computing. For decades, the computing industry has followed a simple idea. The smaller the transistor, the more of them you can fit onto a chip, which translates to greater computing power, reduced energy consumption, and the advancement of technology. But as engineers approach the scale of just a few atoms, many experts believe that traditional methods of chip shrinking were reaching their physical limits, while IBM's latest breakthrough indicates there is still room for advancement. Instead of simply making transistors smaller in the traditional way, IBM completely redesigned their construction by developing a new three-dimensional transistor architecture called NanoStack. The company's prototype packs nearly 100 billion transistors onto a chip about the size of a fingernail, which is nearly double the transistor density of IBM's previous 2 nanometer technology introduced in 2021. More transistors allow the processor to perform far more work while using the same physical space, with the company estimating that this new architecture could deliver either up to 50% higher performance while using the same amount of power, or approximately 70% lower power consumption while maintaining today's performance levels. That balance between speed and efficiency is becoming increasingly important as artificial intelligence systems demand enormous amounts of computing power and electricity, with a human red blood cell measuring roughly 7,000 nanometers across, while IBM's transistor node measures just 0.7 nanometers. IBM believes that chips built with its new 7 angstrom technology could eventually approach 9,000 tops, allowing today's largest AI models to train in weeks instead of months, while consuming significantly less energy. Faster AI training could accelerate everything from scientific discovery and medical research to robotics and autonomous vehicles, empowering breakthroughs that were once thought impossible. The benefits don't stop there, as IBM also reports roughly a 40% improvement in SRAM density, one of the most important forms of memory inside processors, which allows chips to keep more information close to the processor, thereby reducing delays and improving performance for data-intensive workloads like machine learning and cloud computing. It's important to understand that this is not a consumer processor. Rather, it is a research prototype designed to demonstrate what is possible, with industry analysts expecting it could take around 5 years before technologies based on this architecture begin appearing in commercial products. Building chips this small is extraordinarily difficult, as engineers must overcome challenges related to heat, electrical leakage, manufacturing precision, and maintaining high production yields when transistor features approach atomic dimensions. NanoStack was specifically designed to address many of these limitations through its three-dimensional architecture, rather than relying solely on further shrinking traditional transistor layouts, indicating that researchers are finding entirely new ways to continue increasing computing power. This breakthrough demonstrates that Moore's law, the historical trend of fitting more transistors onto chips over time, may still have life left in it, as IBM's technology, if it reaches mass production, could reshape nearly every area of computing. Future AI systems could become dramatically more capable while consuming far less electricity, allowing data centers to process larger workloads without proportional increases in power usage. This new technology not only holds promise for artificial intelligence, but also has the potential to revolutionize various fields, including scientific simulations, weather forecasting, and more, heralding a new era of computing. As research continues and challenges are met, the vision of integrating this groundbreaking technology into real-world applications becomes more tangible, paving the way for a future where computing capabilities surpass our current imagination. The excitement surrounding IBM's sub-1 nanometer chip technology reflects a pivotal moment in semiconductor research, promising to unlock unprecedented possibilities across industries and altering the very fabric of computing as we know it. This remarkable breakthrough not only sets the stage for advancements in artificial intelligence and computing power, but also inspires the next generation of engineers and scientists who will shape the future of technology. As the world eagerly anticipates the practical implementations of IBM's innovative chip technology, the ripple effects promise to transform not just computing, but the entire landscape of how we interact with technology in our everyday lives. The transformative potential of this technology opens doors for startups and established companies alike as they leverage increased computing power to create solutions that address pressing global challenges. With the capability of dramatically enhancing research and development in vital areas such as healthcare and environmental science, IBM's sub-1 nanometer chip technology stands to make a significant impact on improving quality of life and addressing critical global concerns.